Now we are going to study the second layer, that is the Relu. We can say it is the rectified linear unit. Okay. In this layer, we remove every negative values from the filtered image or convolved image, and we replace the negative values with the zeros. And this layer is done to avoid the values from summing up to 0. Like sometimes some values are positive and some values are negative, so it will end up to the 0. So this layer saves from this summing up to 0. Okay. And you know what is the Relu? Basically, Relu is a activation function in the deep learning, and in this activation function, how this activation function works, you can see here. Like for the negative values, for a certain threshold, till the certain threshold, if we have value, then it will convert to the 0, and after the threshold, it will convert to signal as it is. Like if x is less than 0, then it will give you the value 0, and if x is greater than or equal to 0, then it will pass x as it is. Okay. So you can say when input is 0, below the 0, output is 0. But when input rises above a certain threshold, it has a linear relationship with the dependent variable. And when to use the Relu transformation functions, when we want to map input values to a value in a range, like from x to max, it maps negative values to 0 and positive values are the output without any change. So in the case of our convolution neural network, like sometimes if we picked a feature vector having certain negative values, then your convolved image can have negative values, and if you apply the Relu, then what will happen? The values are the negative will be converted to the 0, because in the image there is the in the pixel value there is the no meaning of negative value. Okay, so this is the output of convolved image, and then in this we don't have any negative value, then it will pass as it is in the Relu layer, and when we have negative values, then it will convert negative values to the 0. So these two are the output of Relu layer.